Hello everyone and welcome to another video of Vivek Loans. In the last video of PepCoding Level 1, we had revised this question of largest area of a histogram. Okay, so if we were given an array of bars, like we were given a bar chart and we had to find the largest area which is covered by one or more than one bars, right? So in this video, let's continue the revision and let's revise this sliding window maximum problem. So here we were given an array and we were given a window size k, and whatever elements were maximum in this window size we had to find those and we had to put those in an array. Okay, so let's have it this in a notepad. And so the window size is k, right? So let me first. Okay, so let us consider this itself for now, like this array itself. Okay, and the window size is k. So what we'll do, we'll prepare groups of four. So in these four elements, one, two, three, four, which is the maximum element? Which is the maximum element is 9. So for these four elements, for the next four elements, which is the maximum element? So there also the maximum element is 9. For the next four, it is 8. For next four, it is 12. For these four, it is again 12. So for 12, again 12. And for these four, it is 14. And we don't have any groups of four after this, so we will stop the iteration. Okay. So this will be the last iteration that we make of 12 of 7, 12, 14 because the window size is k. Okay, so yeah, this is how we find the maximum of the sliding window. So how will we approach this problem? So let's say so let us have this as the reference. Okay, like this is the result. Okay, so what we can do, we can have an array which stores the largest next greater element to the right. So the next greater element to the right of 14 does not have any index. Like there is no index to that. So we'll have 10. So we are storing the indexes here. Yeah. So we'll have the index arr.length, which is 9, not 10 here. The next greater element to the right of 6 is 14, so it will be of index 8. For 12, it will be 8. And for 5, for fifth index, the next greater element will be present at index 6. For 1, it is present at index 5. For 8, next greater element to the right is present at index 6. For 3, next greater element to the right is present at index 3. For 9, next greater element to the right is present at index 6 directly. And for 2, it is present at 1. So let us check once. For 14, it is 9 because we don't have any next greater element. So we substitute 9 here. For 6, it is 14, 8. For 6, For 12 it is 8. For 7 it is 6. For 1 it is 5. For 8 it is 6. For 3 it is 3 again, yeah. For 9 it is 6, and for 2 it is 1. Yeah. So this is the next greater element to the right. Like we can consider this as the right boundary. And then what we can do is that we can have I and j. So I, what it does is it is the base, and j, what j does is it will jump from one next greater element to other. Okay. So initially we'll have I and j here. So let's have those here. Okay. So I and j will be 0 initially. Okay. If I and j are 0, then we do, let's say we have this element which is called right boundary RB. Let's say, yeah. So what we do is that we compare this right boundary with I plus k. I plus k meaning 0 plus 4 for when I is 0. So this 1 is less than 4, right? 0 plus 4 is 4. So we jump to the next element. We increment j. Once we increment j, we have RB of 1, which is 6. 6 is not less than 4, right? 6 is greater than 4 basically. So we break the loop here, and whatever is present at the jth position, like 9 is present, so 9 will be substituted into the result array. And that is how we will proceed further as well. So yeah, let's try to solve this question. We have already solved it, but let's try to revise it once. So we can have all this code commented. Let's create right boundary index for right boundary array first. And we'll have to create a new stack as well. Once we create these elements, what do we need to do first? We need to push into stack the last index, right? Uh, so this will be the last index, and then we need to push into the right boundary array. So the next greater element to the right of the last index will be nothing, right? So we push array.len there. Once we do this, we iterate over the array, and then what do? We check if stack is not empty first. If stack is not empty and the element that we are iterating is greater than ARR of stack.peak. If this is fulfilled, then we pop. After this, we check if stack is empty or not. If stack is empty, then we have hit the bottom of the stack. Then we insert into this right boundary of I arr dot length. Else, what do we insert? We insert stack dot peak. Okay, so and we have to push in any of the cases. Okay, so once we get this right boundary and all those things, we get this right boundary. Okay, so now we have to perform this logic. So I will be the base and j will jump from one next to it element to the other. So we can have another for loop which iterates over the arr of I, but we have to restrict this for loop till like we'll have a condition because it should be less than 4 because we have to stop the iteration at 9 minus 4 which is 5. Yeah, so we'll have to stop the iteration at fifth index, right? Yeah. Okay. So we do that and then what do we do? First thing is that we have to bring j, whatever the pointer is present at j, we have to bring it to I. So let me declare j is equals to 0 here as well. So initially both I and j are 0. After this, what do we do? We yeah, we check if so we'll have a while here, right? While rb of j is less than I plus k, then we increment j, right? Rb meaning right boundary, correct? Yeah. So we increment j, and once we are out of this loop, and if I is equals to j, then we haven't we haven't gone in this loop itself. So there is no element which is greater. There is no you know element within this window which is greater. Okay. So we'll have if I is equals to j, then or we'll have another condition as well. If RB of right boundary of j is equals to arr dot length, then also we'll insert result array of I is equals to arr of I, correct? And in the else condition we'll have result array of I is equals to arr of j, because whatever jth position is present, so if j is present here, we insert this element. Okay, like 9 we have to insert. So yeah, I think this might work. Let's try to run it once. For 9 length, right? We have 2938 3 12 6 and 14, right? And we got array index out of bounds exception for line number 69. 69. Okay, but why did we get that? So we'll need to, okay, so we aren't doing the right thing here. So the condition will be from AR dot length minus 2, and we'll have to iterate till I is less than or equals to 0, and we have to do I minus minus. Yeah. And we are not printing it. So let me print it. Let me run it once again for 293. Yeah, let's compare it once. I think we missed the last part. Okay, the output is different. So what we can do is we can print the right boundary first. Let's check if we are getting this properly. And once we get it, right boundary of j is equals to, yeah, let's run it once. 2938117. And we are not getting the proper right boundary itself, so we'll have to check the logic. So if we are not iterating properly, I is less than, okay, we'll have to have greater than or equals to 0, right? I is greater than 0, yeah. 381712, right? Yep, let's compare these. So the last element that we are getting is 14. So, but the one that we have got in our answer is 7. We are getting 9, 9, 8, 12, 12, and then 7. Okay, let us check the inputs ones. 29381, 7, 12, 6, 4. Yeah, let us check these as well. Yeah, so these also looks fine. So let us check our logic ones. So we'll iterate till ARR dot length minus 1, meaning 5, 5 minus 4, 9 minus 5, 9 minus 4, which is 5. Okay, so when I and j is 5, and if right boundary of j, meaning right boundary of j is, right boundary of 5, which is 7. 7 is less than 5 plus 4, 9, right? 7 is less than 9. That is the first condition. Yeah. So what will happen is it will increment 7, increment J. So J becomes 6. Now 6 meaning 12. 12 is less than 9. No, not 12. My bad. So we'll have right boundary of J, right? So right boundary of J is 6. Okay, we'll have 8 and then 9. So we should have at least got 8 here, right? Mm, let's check. If right boundary of G, meaning a right boundary of 5, which is 6. If 6 is less than I plus J, I will be 5 plus 4, 9, right? Yeah, so then we do when we increment J and then we have 8. 8 is less than 9, so then we again increment J. So we have 7, we have J as 7 now, so again we get 8. Then then we again increment J to 8. Then we get 9. Okay, so 9 is not less than 9. So this should break. And then if right boundary of G, meaning right boundary of G, meaning 9, right? 9 is equals to array dot length. Then we insert result array y is equals to arr dot length. No, this is not what we should do. So we have this condition wrong. So if we'll have one more condition here in else if, then we'll have to insert, then we'll have to insert the jth element only, right? Whatever is present at j. Yeah, we'll have this condition. Let's try to run it once. Yep, and we get the desired output that we have. So yeah, that's all for this video. In this video we have revised this sliding window maximum question that we had already done. So see you guys in the next one. Thank you.